Hi, and welcome to Serious About Sustainability, the podcast series brought to you by Mitsubishi Electric's Ecodan air source heat pump. I'm George Clarke, architect and Ecodan Ambassador, and our show today is called High Temperature Heat Pumps, the Future. My guests are James Chaplen, Head of Product Marketing and Communications at Mitsubishi Electric, and Rob Hicks, Asset Sustainability Manager at Sovereign Housing Association. Welcome to you both. It's great to have you on the podcast today. James, I'm going to come to you first. Mitsubishi Electric Ecodan have launched the R290. Tell me about it.
Yeah, so we've recently launched Ecodan R290. What this product is now enabling us to offer to the market is high flow temperatures, 75 degrees, all the way down to minus 15 degrees ambient temperature. And at the same time as offering those high flow temperatures, we're also dramatically reducing the embodied carbon of the product as a function of the global warming potential of the refrigerant. And that is now 75% less than our current product offering.
Which is incredible. So it's setting new standards for performance and sustainability.
Yeah, for sure, definitely.
What is a high temperature heat pump?
So heat pumps have been, especially in residential settings, they've been evolving over the past 10 years. Typically, heat pumps in a residential setting have been seen as lower temperature. So heating temperatures of sort of 55 degrees or less. High temperature heat pumps, especially in this sort of setting now, are able to meet the type of temperatures that we would see with a traditional type fossil fuel type system. So we're talking flow temperatures with our new product that we've just introduced, the Ecodan R290, of up to 75 degrees Celsius.
And tell me about the R290 and why it's a game changer.
So the R290 is referencing the refrigerant of the product. So as I say, we've been on this journey of evolution with heat pumps in the residential setting over the past decade. That's mainly been around the refrigerant and technology upgrades, control system upgrades. The R290 means that we can now, it's got a much bigger operating envelope, which means that we can offer higher temperatures at more ambient temperatures. It also dramatically reduces the global warming potential of that particular product, and that is a really big function of its embodied carbon. So the amount of carbon that is required to create that product in our factories and move it to somebody's home is now 75% less than what it was with our current product,
which is amazing.
Yeah, so it's really it's a real step forward, in our technology. And
why would high temperature heat pumps be ideal for retrofit applications?
So existing, if we look at a sort of typical home built in the 1990s, that system is probably going to be a gas boiler system. Over 80% of homes in the UK are running gas boiler systems. The flow temperature in that system is probably going to be somewhere between 65 to 80 degrees going out to the radiators. So when we've been looking at retrofit opportunities with the sort of current product that goes out into the market, normally there has to be some sort of infrastructure upgrade in terms of the emitter system to be able to produce the same amount of heat in that property, but with a lower temperature. So what moving to this new technology enables us to do is offer a higher temperature, which means that those major alterations may not be needed, which has been a big barrier.
And when you say major alterations, you talk about radiators?
I'm talking about mainly the swapping out of the existing radiators to new radiators. Although now this technology exists, we have got to be careful in the application, because the higher we run the temperature of these products and this technology, the more it does cost. So there has to be a balance between the barrier of rolling out this technology in the mass market, which is where we're going, and the cost to the person who's operating it in terms of every month seeing a substantial increase on the amount that they're paying for their fuel. And to be honest, that's really a function of energy costs.
Yep.
So in the UK currently, and I looked this morning, the ratio between gas and electricity is about 3.8.
Yeah.
So electricity is about 3.8 times the cost of gas. And we know with Ecodan that once the flow temperature from that unit starts to increase above 55 degrees, that's when that ratio means that it's going to cost more to run the heat pump than it does the gas boiler.
Yeah.
So we need to be aware that that is a situation that we face. Now, if you look at somewhere like France, where that ratio is 2, that is a completely different situation and proposition, because that then does enable us to run at a higher temperature if that cost model changes.
So how do we overcome that cost problem? What would be the ideal scenario?
So there's things that we can do now, and there's things that are sort of outside of our direct control that we continue to try and advise on and look to try and create change. The things that we can do now, and where we see this product's position being ideal, is when we get into a situation where in that property we're sort of looking at the all electric home. So we may have solar PV, we may have battery storage, we may be able to access a time of use tariff. And what we're doing there is essentially we're taking control of being able to create a free or cheap electricity. And when we're able to do that in the home, then that ability to be able to drive the product to a higher temperature means that we can make use of really high density energy.
Yeah.
And so we can store that in occasions. So say you're able to access the time of use tariff, you have 5 hours where electricity is, 12 pence per kilowatt hour. We can control the Ecodan in such a way that we can make use of that period of time. We can store energy in a buffer tank, say at 75 degrees, and then we can use it at a later point when electricity is really expensive, and then take that out into the emitter system.
So just stepping back a bit, what would you say were the key benefits of the R290?
It is temperature, it's embodied carbon. There are some other technical bits, like
that I wouldn't understand.
Yeah, modulation and controllability and other things. But really, the headline things are this product is now enabling the market to match the existing heating systems that are out there. So that challenge of rolling out heat pumps into mass market becomes a lot easier. We just need to, as an industry, be aware of what the implication of that is at the moment with the current cost model, energy model.
And you're saying the
UK.
implication is that when you're pushing it to the higher temperature to match the temperatures of fossil fuel boilers, that could potentially cost more money, but you could offset that by putting in other measures in your house like solar PV, battery storage, using electricity at a cheaper rate, at off-peak rates rather than high-peak rates.
Yeah, so it's a very similar type model that is already existing with charging your car when the electricity is really cheap, or charging a battery pack when the electricity is really cheap. We're just now storing that energy in a different way in water, essentially.
So what could be the longer term use of high temperature heat pumps?
So I think those things that I've already mentioned about being able to access and use the product in that sort of ecosystem, that still is going to continue to evolve and develop. But the long term future is that we get to a situation as levies start to change in the energy in the energy mix. So we start to see shifts from levies on electricity moving elsewhere, and we already see it in the market. The cost of electricity for certain tariffs is starting to reduce, and in that future, when electricity becomes maybe similar to the France model, then that rollout of retrofitting this type of technology into our existing housing stock becomes one where that end user is very unlikely to see a cost increase for that in terms of an operational cost.
It's tricky at the minute, isn't it? Because we are very much in like a transitional period where we want to step away from fossil fuels. We don't want to be using gas boilers anymore. We want to go to electricity. But fundamentally, electricity costs more money than gas at the minute.
It does, yeah.
That's the fact. That's got to shift. That's got to change.
And these products are exceptionally efficient. You know, if you look at the product that we have just launched, the Ecodan R290, even at the average UK low temperature of like 7 degrees, flowing at its highest flow temperature of 75, it will still achieve an efficiency of 2. So for every kilowatt you're putting in, you're going to get 2 kilowatts out. And for any, that's a very, a really high efficiency. For when you compare that to what we're currently, what's currently in most housing stock, which is 0.8, 0. At best, really.
So just getting slightly more technical, tell me about the refrigerant itself.
So the refrigerant is classified or spoken about as being a natural refrigerant. It's a hydrocarbon, a HC. There is legislation and regulation which is driving the use of refrigerants more towards lower and lower GWPs, and we've just seen the latest close to the consultation of F-gas in Europe, where the UK is very likely to follow, and what that means for this type of technology, so the sort of heat pumps that we see in our homes, is that by 2027 you won't be able to install a product which has a refrigerant with the GWP more than 150.
Yeah. And GWP is global warming potential.
Global warming potential, yeah. And so there are other refrigerants that we could have used. We've seen that piece of legislation coming down the road for quite a long time, but the next steps are more and more steep. So, we took the decision, like some others, to just go straight to the lowest GWP that we could in terms of the refrigerant. So, that's one big benefit. The other benefit of that particular refrigerant is that it has it offers a much wider operating envelope. So the temperatures that you can achieve with that particular technology compared to what we have at the moment really, really widen. So we can now offer 75 degrees as a leave-in flow temperature out to the heating system with all the way down to minus 15 outdoor, which will cover pretty much every situation in the UK. And there's a couple of like real world benefits, not only in the temperature that we can give out to now the heating system, but heat pumps have always one drawback has always been that when we're trying to pasteurize for sort of Legionella, because we have to store hot water, every sort of 2 weeks, we have to bring the temperature in that tank up above 60 degrees Celsius. And with the current technology, you have to rely on an electric immersion to be able to do that. So with the using this new refrigerant, having that wider operating envelope, all of that can now be done with the heat pump. And if we then think back to having a efficiency rating of 2, even when it's cold outside, that's double as efficient as the best immersion is going to do to lift that tank temperature. So those are also sort of the big wins that we can see with moving to this type of technology.
And so just to summarise then that, what do Mitsubishi Electric Ecodan hope for with the R290? Just kind of looking ahead, if you're going to speculate and think 2, 3, 5 years ahead.
So it's the technology of the future for us. We're on a transition period now, which will see all of our products move over to that type of refrigerant. And like I say, because it now offers us that ability to be able to roll the technology out to existing housing stock potentially without major alterations. The technology now exists to do that. We just need to work on everything around it to make it the best the best solution for our customers and also the people who are going to end up using it.
Yeah, so it's brilliant for retrofit. It means you don't have to adapt radiator systems, but you're acknowledging the fact that to push that to higher temperatures could cost more money with your electric bill. You would then have to put other measures in place to kind of offset that until things change in the wider energy industry.
Exactly, yeah.
But the fact that it's matching the high temperatures of current fossil fuel boilers is quite amazing, really.
Yeah. So it's the first time we've seen that in with heat pumps for residential applications. Yeah.
Brilliant. So Rob, we've met before.
We certainly have.
A number of times. Welcome to the podcast. Tell me a little bit about Sovereign Housing.
So yeah, Sovereign Housing. We've recently merged with Network Homes, so we're now Sovereign Network Group. We have 86,000 homes. And
you are the Asset Sustainability Manager.
I certainly am.
Title.
It is. I work in client services. We're a support function, back office. We look at vision, strategic direction, support, help, guidance for operational teams and our management teams on the type of directions that we would go all around the sustainability of a home. So we have a real responsibility, but we also have an opportunity to fundamentally change that marketplace for our customers.
And you've got 86,000 homes. Just give me an idea about what that kind of housing stock is and how it varies.
So we've got that all across the board from a brand new homes, and we look to develop around about 2,000 new homes a year. And obviously we've got a broad spectrum of stock ranging from turn of the century right the way through to a core which sits in 1950s, 60s, up to the 80s, all the way up through. But we have a roadmap for obviously that.
Okay, talk me through the roadmap. Roadmap for change.
A roadmap for change. So we have a sustainability strategy, and it sets out three clear points for our sustainability. First is to try to achieve all of our homes to an EPCC by 2035. Then an EPCB, sort of 86, 87 as an RDSAP number by 2047. And then grid decarbonisation should pull us in around about 2050 to be carbon neutral.
Which is amazing.
It is. It's a lot of work. We're already underway with that. So we've been underway that now with our EPC2C by 2035 program. It's our third year. And we've made some real advances. So we've seen a 40% reduction in homes, pulling them closer to that magic C line. Because obviously you're really interested in fuel poverty, and that is one of the factors of fuel poverty, how to measure it, isn't it?
Yeah.
What a home will actually provide. And that's key. And that ties into what R290 could potentially do for us, not only in decarbonisation, but running cost and comfort for our customers.
Sovereign Housing have been using Ecodan heat pumps for quite a long time now.
14 years we've been on this journey.
14 years.
Yeah.
But what challenges do you face in decarbonising your housing stock, particularly with retrofitting?
So retrofitting is in decarbonisation is about making sure that we have a holistic approach to the whole home. If we take some of these products, they're fantastic, but then when you put them together in the right way, they become truly exceptional, don't they? Like James has already said, an air source heat pump, you put £1 in and you get £3 back. That physics can't change. That's exceptional. The fuel to your home is delivered to you free of charge, and it's always there. It's never late. There's no cost to it. It's amazing. I just I can feel myself grinning inside because it's just astounding. So the challenge we face is about finding the right solutions that will suit us and understanding which roads we're on and how long we're on them for. Because some solutions will be short term, some solutions will be much longer term. So new build, where we have a new canvas, we should be looking for a much longer term solution to those homes and making them to this 87B, this line where, in theory, when the grid decarbonises, those homes decarbonise. So they're coming at it from that angle. We're coming at the retrofit angle where we say, okay, at the moment, this is what we can do. But we can see vision of where R290 could take us, and that could push us onto another road. And I actually think the use of those air source heat pumps is a given, just from the global warming potential. we've one blue planet. Why wouldn't we? And then the unit can do so much other things. It can go to 75 degrees if we choose so. Yes, there will be a balance of cost, but how much is that cost? We have life cycles. So we want heating systems that have been put in new and need to be replaced from a gas boiler. It's 12 years old. We can't be going into people's homes and thinking it's a great idea as an enabler to say, we're going to change all the radiators, we're going to change all the pipes, we're going to have all the carpets up, everything, all the decoration. You know, they may have spent 10 or 12 years in that home.
Yeah.
Got it just right.
So from Sovereign's perspective, what impact will the R290 have?
So I think the R290 will take us to in a place, if we just think about the GWP, the global warming potential of shifting from R32, 675 to 3. You might as well call that 0. It's such a low number. I think that's a game changer just for the planet alone. That would be a reason enough. But I think it's the other things that it can do. It can then integrate potentially into existing heating systems. Now, we've been on the road with air source now, looking at our off-gas grid for a long time, and that's pretty settled. We know what we're doing. But we've got an on-gas grid, and that's going to be a tough sell. You've just been talking about tariffs and how much it costs, and I have to always think about comfort, cost, and carbon.
Yeah.
And that's a really tough sell.
So from a comfort point of view, how do you see it?
So for a comfort point of view, clearly the technology can deliver absolutely 100% at a much better efficiency ratio than gas.
And from a carbon point of view?
Instantly there, isn't it?
And what about cost?
So cost is the one thing we have to just wrestle with, which is where it changes. And I think of it as revving a rev meter. So the units with weather compensation and correct design, even if we integrate them into an existing gas system, they're still going to spend a lot of time in the green zone, working at the lower temperatures, the better efficiencies, the right cost factor. Every now and then they're going to go into the amber and red zone. So when they go into that amber and red zone, how much is it going to cost you in your home extra to achieve that? Nobody really knows. And that's where we want to go with our home and place trials. It's to actually physically design it, put it in, test it, learn from it, track it, and come out with an answer that says, it's about £100. Well, that feels reasonable in the balance of not having to chuck heating systems away because there's early replacement by 24 years. There's not extra steel because the radiators have to be a little bit bigger. There's not copper pipe, plastic pipe, all the stuff that went into putting that in homes, let alone the biggest factor, which is disturbance to residents, to our customers. When you put that together as a holistic picture, you go, well, it's hardly a couple of tins of paint, is it really? So I think that's where it can take us. And I think that's where the magic of it's going to be as we start to learn and go down that road. And we've got a lot to learn.
And it's interesting because you talked about a kind of holistic approach, looking at
Absolutely.
the home in its entirety.
Yes.
If you were going to kind of predict what the outcomes of your trial might be, and I'm sorry to put you on the spot because that's probably not good research planning, is it really? But what would you imagine you might have to do, or what things would you be looking at to offset the problems with cost?
So I think that the cost is obviously the tariff, and that needs to come from the generation of clean energy at a low cost. And so that it is a comparable balance of a kilowatt of gas for a kilowatt of electric, what it can actually do.
So that's again a national grid.
That
issue,
is, absolutely. I think then there's a balance of self-generation and storage on site so that we can generate some of it and offset that. But obviously that has to sit very well with the cost of that self-generation and storage. I think then there's the ability to decide these units can be driven when necessary at that higher temperature. Now that's in a steady state arrangement, that's only going to be from -3 upwards because that's how all the designs work. So how far are we going to go, be in the -3 to the sweet spot of +7 to 15, 20? That's the amber red zone we're talking about. How much is that going to cost? Because in reality, that's if I came to you and said I was going to do this, you'd go, Rob, how much is it going to cost? I don't, all the maths, I'll leave that with you. Thanks.
Yeah.
How much is it going to cost me? If I go about £150, or we can replace and upgrade all the radiators and we can get you a much better efficiency, but we're going to have to throw away all that stuff, which could be madness. It needs to be at the end of its working life to be sensible, but that could be another £2,000, £2,500. You go, okay, I'll stay on this road for a little bit, and then when it comes to its natural life cycle end, and it can be recycled properly, and we can get this holistic view of it, then we'll then go to that absolute degree of efficiency. This is reasonable and practicable, and a solution that will enable us to get to net zero. Does that make sense?
Absolutely, yeah, it does. And what about government help? Like, is the funding available to decarbonise social housing?
Yes, in practical terms, it's we've been lucky, and we were successful, and we won our SHDF bid, Social Housing Decarbonisation Fund, for 1,000 homes. So we're underway with that, but that's holistic view. We run it on a holistic view, making sure that you look at the 5 or 6 key components. Fabric first, no matter what the fuel source. It drives me insane when people talk about fuel sources and they go, oh, of course, when you put an air source heat pump, you'll have to look at the fabric. No, you do it with any heat source because you want to reduce. That makes sense.
Absolutely. Yeah.
So we look at the fabric, the walls, we look at the loft insulation, we look at the windows, we look at the doors, we look at air tightness, we look at a ventilation solution, and then we pick a great heating system. So air source heat pumps have been at our core for that work for the last 10, 12 years.
And I think I might know the answer to this question, but what about funding certainty?
Now, that's what we hoped from the SHDF was that we would win our bid, and then there would be a clear roadmap of then funding available. And once all that work's done, because it was a huge piece of work, is if we're then asked to bid again, we go through all that whole process. Surely there could be a more mature arrangement, say, well, we can see what you're delivering is value for money because we've done the analysis, and part of winning means that you do all of that analysis. So why can't we fund on a roadmap that is laid out and allows us to not negotiate, but actually have an adult conversation about that, I think.
And according to the National Housing Federation, the full cost of decarbonising existing housing association homes will be about 36 billion on top of the money that's already been committed.
Yeah, on top of our repair and maintenance bill as well. Yeah, I'd agree with that.
Yeah, it's cheaper than HS2.
Very, very dirty maths, somewhere between £15,000 to £60,000 a home.
Right, okay. But that's a big step to say you're going to decarbonise an existing property. It's huge, isn't it? I mean, that seems like good value for money.
And we do evaluate those homes that investment will have also a timeline and a life cycle, because some homes will only be able to go so far, and we'll have to accept that. Other homes will be able to go all the way, and I think we need to balance our portfolio of new homes coming in that are already there, looking at older homes to see what we can do and accept where their energy efficiency journey is and where it may well end, or where there may well be a sensible cost or practicality to it. There are listed buildings, conservation areas, all that type of stuff. So in broad brush terms, for a cavity wall home, modern timber framed, whatever the construction is, whatever its location is, really we can get them to those EPCBs. That's a given, and it's not really that much rocket science, is it? When you think about it, we just need to understand some of the products like the R290 that are going to enable some of the stickier challenges, conversations, trying to move us from that gas reliance to that electric. But we need to have that in a very mature way that people are very clear about what cost it will be, not only from the running costs, the affordability, the warmth, but the capital cost of investment and the operational cost for us. Because ultimately, our customers, our residents, through their rents, pay to enable all that. So we've got to do stuff in a very meaningful way that actually does what they need. They want great homes that are affordable, they're warm, they're secure, all those things. Yeah. And they want it to be simple to use, all of those things.
Yeah, and I realise we are in a kind of transitional period and we need lots of other things to change, like the unit cost of energy from the grid. But do you think the R290 Ecodan could lift more people out of fuel poverty in the long term?
So we've done an awful lot of work on fuel poverty because obviously, as I mentioned earlier, that it clicks into really two things: the energy efficiency level of your home and your relative income after your housing costs. So I believe that with the right level of tariffs for the cost for fuel, the ability of R290 to convert £1 to £3 and still convert £1 to £2 at 65 degrees, and we don't want to rev into there very often, I think it's fully capable. When we talk about fuel poverty, we've developed our own assessment tool, took the BRE methodology, which is 119 pages or something like that. It's a great read, even after the sixth time. So we use that to assess people's position and really find those people most in need. And we use them within our energy efficiency programs to prioritize them. So we will instinctively want products that support the ability to lift people out of fuel poverty. Because if you know the driver, the home, its energy rating, and there are derivatives of that, and you know income, then we know where to focus our light, our torch, on which one is it. And there's stuff we can do, and then there's stuff we can help to enable our customers. Does that make sense?
Absolutely. And you seem very excited by all this.
Yeah, absolutely, because there's so much opportunity for people, and we're part of that enabler, and it enables people. If kids are growing up and they're growing up in a warm home, it's just astounding what they can do. They're the next generation, aren't they?
Yeah,
they're going to be sat here potentially at some point, trying to guide, influence, talk about the future. So yeah, it's really an important role that we have and responsibility.
Yeah, I always think it's fascinating when you talk to kids about home innovation and green technologies, and they think the gas boiler's bonkers.
Yeah, I've got, my two kids are like, why are we still doing it? Why are we doing it? You need to change. And
what do you say to them?
I said, well, there's a pace of stuff that we can do. Some stuff can be done quickly, some stuff can be done a little slowly. There are different swim lanes, so don't think we're always just on that one lane. The prize is over there, and we've got to work out how to get there.
Fantastic. So there you have it. High temperature heat pumps, the future. A huge thanks to my guests, James and Rob. Thanks for watching, and until next time, goodbye.